This lesson will introduce you to using the command line shell. You will need to log into your Future Systems account via SSH. Parts of this lesson have been adapted from the corresponding software carpentry lesson. Please see the software carpentry website for more details. A shell is a program that facilitates interaction between human and computer. By providing this level of abstraction, certain tasks which may be otherwise cumbersome or time-consuming are relatively simple to accomplish. There are numerous types of shells. If you have ever used a computer, you have used a shell. For instance, Windows on Mac OS X use a shell based on graphical representation, using a mouse and keyboard for interaction. Touchscreen phones and tablets also use another type of shell whose mode of interaction is through touch. In addition to these, which you are familiar with, we will be using a command line shell to interact with the computer mainly through the keyboard and text. The purpose of this lesson is to explain how the shell relates to the keyboard, the operating system, and the user's programs. To start with, we will follow Nell Nemo, a marine biologist who needs to process and analyze her data. She has 300 samples and needs to run each sample through an assay machine. The output is a file with one line per protein. Calculate statistics for each protein using a separate program called GUStat. Compare the statistics using another program called GUDiff, and then write up her results. Some good news is that it will take only 2 weeks to assay all her samples. Unfortunately, though, if she were to run GUStat and GUDiff by hand, it would take 45,150 calls. Even if it took 30 seconds per each call, it would still take over 2 weeks of non-stop, perfect work. Nell is only human though, and there is a better way to accomplish her goal. The programs she needs to use can be called using a command line. She can write a series of commands into a file which call the GUStat and GUDiff programs, and have another program interpret this file. This is called scripting. Let's look at the basic components of a shell. In order to interact with the computer, the shell presents a prompt. By entering a command at the prompt, you direct the shell to do something. These commands are typically small units that can be glued together somehow. Let's start with a simple one, the whoami command. We'll begin by logging into our account on Future Systems. You are now at the command line prompt. This is where the shell expects you to enter commands and text, which will then attempt to execute. Let's start by executing the whoami command. We'll type whoami, and then press enter to execute it. So what happened when you pressed the enter key? The shell first found a program called whoami, ran the program, displayed the output, and then displayed a new shell prompt to indicate readiness to accept commands. The file system is the part of the operating system responsible for managing files and directories. Files hold information, and directories may point to other files and directories. Naturally, there are some shell commands to interact with the file system. One useful command is pwd, which stands for Print Working Directory. Let's execute it and see what happens. The output is a / separated series of names. Since I just logged in, this particular path is called my home directory. To understand what a home directory is, let's have a look at how the file system as a whole is organized. At the top is the root directory, which holds everything else. It is referred to using the single / character, whereas the leading / in a path. The names that make up the path refer to either a file or a directory. We can list the contents of a directory using the ls command. Executing ls by itself will list the contents of the current working directory. We can also pass a path to ls to inspect its contents without needing to change directory. Let's list the contents of root. Notice that there are several names listed. We don't know which are files and which are directories though. We can pass a parameter to ls to ask it to be more helpful. Now we can see that the names that are showing with a trailing / are directories, and the others are files. Let's list one of the directories, the bin directory. Notice the error message. This happened because there is no file or directory called bin and the current directory. Since we forgot to specify that we are referring to the bin directory relative to the root, let's specify the absolute path to bin. We can also list the current directory in two ways, with ls. You may recall that ls with no parameters lists the current directory. We can also find the path to the current directory and pass that to ls. Of course, you would use your username instead, though you are welcome to try mine and see what happens. What if we wanted to change our current working directory? So far we have used pwd to print the working directory and ls to list directories. We can use the cd command, short for change directory, to change the working directory. Additionally, there are some special notations for referring to the current and parent directories. Let's try changing directories. Use the cd command and pass in the path you wish to change to. Now we can check that the current directory is now changed. We can also use shorthand to refer to the current directory and the parent directory. The single dot means current directory, and the dot dot refers to the parent. One useful feature of the shell is tab completion. This will ask the shell to fill in as much of the path as possible or list possible completions when you hit the tab key. Let's try it out. Let's say I wanted to list the contents of /n/India. At this point I can hit the tab key once, and the shell fills in the rest of the path. Let's try another one. This time we'll do, and we'll hit the tab key again here. Nothing happened, so we'll hit the tab key again. This makes the second time. Now list the options available. We have the choice between scratch and soft. Let's just add the O and hit tab again, and it auto-completes. We now know how to explore files and directories, but we still can't create anything on the file system. We are missing the ability to create directories, modify files, copy files, move files, remove files, and directories. There are several commands that allow us to do these modifications. Let's create a new directory called suse. We will then write a couple files, remove them, and then remove the directory. We can create a directory using the makedir command. Let's now create a file called fish with some text within the suse directory. Let's now copy fish and update it. Realizing that we gave the file the wrong name, we need to rename it using mv. Now let's update it again. Now let's try and clean up after ourselves. We can try deleting each file using the rm command. Or we could recursively remove everything from the top directory. The rmdir command means remove directory, so let's try that. Turns out that rmdir only works for empty directories. This might be a good thing since we don't want to accidentally delete our work. In some cases, you may actually want to delete a non-empty directory. You can pass a -r flag to rm to do so. Be careful though. What you remove with rm or rmdir is gone for good. Now that we know the basics of moving around and modifying the file system, let's look at some more useful commands, namely redirecting the output of one command to a file or directly into another command. We will also see globbing, as well as a few new commands to manipulate text. I have a list of files containing information about the shape of various molecules. I would like to get the 5 smallest and 5 largest. The word count command, wc, can give me the number of lines in each file using the -l flag. The *.pdb means match everything that ends with .pdb. I could also select everything using just an asterisk. I can also filter based on the name to match the acids. Or to get the alcohols. Since I want to get the 5 largest and smallest molecules, I will need to sort the files by their size. Let's first write the line counts to a file using redirection. Now I can sort the file using the sort command. You have to specify the -n flag in order for sort to properly work. Try it for yourself without and see what happens. Let's now write the sorted lengths to a file for inspection. We can get the first few lines using the head command. We can also get the last few lines using tail. You have to specify -6 for tail because word count automatically appends a single line containing the totals. We have now solved our problem, but there is another, more efficient way that doesn't require intermediate files. In order to get the smallest 5, we can do the following. The vertical bar means pipe the output of the command on the left into the input of the command on the right. So in this case, the line counts pipe into the sort command, which pipes into head. Similarly, we can get the largest 5. We've only touched on the very basic tools of the shell. You can find much more information on the course website, the Linux Documentation Project website, and everyone's best friend, Google.